Alright, so I have done. Oh. Okay, that is working. Cool. So, I am. Hopefully, I fixed some of my audio problems. Would also help if I actually got my beautiful face on here too, wouldn't it? Come on. So, I have gone through, since last stream I've gone to the liberty of refactoring a bunch of stuff. Namely, I've renamed ARC to K-Array. So here it is. Stuffs. I just need to get OpenGL working this stream, or at least first. I just need to get. Coughing fit. So I just need to have. Okay, so I've refactored ARC. I've renamed it to K-Array. I've changed it to a STD vector. Right, so that it's autonomously expandable. I tried to implement this myself, but I just could not get it to work, which is, you know, lovely, but things happen. I've also had to change how a few things work, right? I had to have val equals head at minus because head is one index past the actual end of the index. So val is just whatever. Yeah, so I have a t-val, which is at the end of the line, and then the data at the index is equal to whatever the data at the head is. Wait. Actually, this needs to be end t and t val is equal to data at index. That's important. And then return the val. And then data at index is equal to data at data end. Which means end doesn't need to have a thing. I can change that to this. Yeah. This is correct. Because I don't need to, I don't need to pull whatever's at the end of the index, at the end of the array. I just need to pull what's at the beginning, or whatever is at the specified index. That's what you're pulling. Right. So I have that. There weren't any issues because I don't actually implement that particular stuff. I started to work on a map, an unordered map, but that's the thing. I also have a logging system for reasons. Yeah. So this took like 2 days of bashing my skull against my keyboard for it to actually start working. Which is, you know, absolutely wonderful. So fun. Then go, and this also had lasting effects in like the empty component system, right? So for component first, what did I do? We have the get ID, we have the K-array data, and we have the map for indices, but I also needed to have a K-array for the entities themselves, because I need to be able to, given an index, find the entity so that I can do some stuff, and I'll explain why here in a little bit. Another thing that I changed was, what else? Entity, I think entity changed. I don't know about the actual, not within here. I changed it a little bit so that it could return a pointer, so that we can return a null pointer, so that we can check to see if it's valid, so that we can see if the entity actually has the component or not, in multiple different ways. The fast way, which is to use a set for comps, but I think that there's different ways of handling this. For instance, it would be very easy to have it'd be more computationally expensive, because you can always trade speed for memory. So this takes up a lot of memory, and this takes up more memory, but it's faster. Right? Or at least should be faster. Right. Comp indices. Find this ID. Yeah, so you return a null pointer, so you can do this, but I don't know how fast that function is, especially on large sets. I'll have to think about that at some point. So I had to change both the addition and subtraction operators to accommodate for everything. For instance, like when we add it, we want to add the component to the entity. We want to add the entity to the indices. Then we push empty data. We push empty data into data. We push an empty entity into entities. And then we effectively just do the things that we need to do. And we also insert the entity into the entities as well. Right. And then we broadcast that the entity has changed, and we return the information. Okay. Return a reference to it. Now, so the subtraction operator is a lot more interesting. So we have to find the old index. We have a temporary data at that old index. Also find the old entity, which we pull. Right, we pull the data using the old index, and also pull the entities using the old index. Then we erase the component, we erase the index, and then if the entity's count is greater than the old index, then we know that the old index was the last one. So we do things a little bit differently. Create indices. Yeah, if the count is still right, if this check fails, right, then that means the old index was the last one, which means that the count is going to be equal to old index. I love you. which means that the old index was the last entry. Otherwise, what we could do is we could just kind of like leave stuff, right? Because all of these things will effectively what happens is that these two K arrays get synchronized. Everything works out. And then again we update the component. System hasn't really changed much. We can go into the implementation to take a look at how things changed here. Entity, it's still the same. You just read through all that and erase them. That's another reason why we want to, well actually that doesn't matter. Components is still empty. It's all templated and stuff, so that doesn't matter. System, yeah. System init, system update, and then this component changed. So first we have to make sure that the set contains all. We assume it's true. And then we just see if the entity components count component. But this is a thing here. Interesting. And then if it contains all, we insert the entity. If it doesn't, then we erase it. It's just a different way of doing signatures. This is slower than using signatures, using the bit set, but it's easier to maintain. Here's just a thing so I can use it for debugging. I don't need that anymore. And then the same thing for update list. So let's figure out how to do all this. Now I would like to use bufferless rendering. The problem is that I can't get it to work, and this is absolutely aggravating because I use bufferless rendering all the time with OpenGL. Like, I use it so often. It is absurd how frequently I use bufferless rendering. Okay. Because I use it constantly when it comes to... You still need a VAO when using the core profile. Oh. A non-zero vertex array object must be bound, though no objects have to be enabled, so it can be freshly created. So it can be a freshly created vertex array object. The compatibility OpenGL profile makes VAO object 0 a default object. The core OpenGL profile makes VAO object 0 not an object at all. Am I using the core? So it needs to work. So I still need a VAO, a dummy VAO, in order to pull this off. That's why it's not working. Okay. So that's why. That's good information. Why is this? Okay, it's not updated yet. Drawing a triangle. Where's the VAO stuff? VAO ID. There's so much going on. So So I don't need the vertex attribute pointer. And I also don't need to enable the vertex attribute. I just need it bound. So I still need these things before where? I could probably do it here. Let's see. When is it doing it? Yeah, all this stuff is happening after it's all linked. So after the program is linked, you can still do all the VAO stuff. Okay, so links VAO is equal to so then it is GL gen vertex arrays. So one, and just do a VAO. Yeah. And then GL find text array. This is VAO. Correct? Yeah. Buffer from which position will receive its data and the format of that data. So that's finding the buffer. Okay, so all this is the buffer stuff, right? So it is still VAO. So now, in theory, hopefully this should work now. As long as I have all the ordering properly, and I should get some kind of something. Yeah. Hopefully. We shall see. No, still don't have it. Let's do things a little bit more verbose. Sometimes things being verbose is a good thing, right? So vec2 vec2 so we have vec2, and this is say minus 0.5, 0.5, and then this is vec2 0.5 minus 0.5, and this is vec2 0.0, 0.5. Okay. Position at GL vertex ID. I do believe this is how you assign things, right? I have to look. Points for 2. Yes, this is how you do it. Okay. If this doesn't work here, I'm stuffed. Okay. Still nothing. So we have Veil Gen buffers. So, am I doing things a little bit wrong? So, on the side, you still need a VAO when using code it generates. Okay. So there are some things that you can do. Because it's really nice to algorithmically do all these things, right? Find vertex array. So you still have the VBO. Why is the VBO a thing? Do I still need the VBO? It becomes more pronounced in the lower APIs like Vulkan. Full screen pixel shader pass requires a lot of boilerplate code, setup code, something like this. Use before rendering. When rendering without any buffers, the vertex shader will simply be invoked the number of specified times without input. General arrays, GL triangle, 0, 3, since we're assuming the first use as usual. And simply move the constant vertex versus array into the shader, or even compute on the fly like this. We have to use GL vertex ID to generate a triangle without vertices. There's the final vertex shader. There's one little snag: you still need to use a VAO when using the core profile. So how do I... Okay. Oh, does this have to be a thing in here? Or can it just be a thing? Yeah, position vector. Weights. Layout location 0 out. Oh, am I just a dumbass? No. GL frag cover. Hold up. Is that a thing? GL frag color? Am I an uber dumbass? Wait, I thought fracking shaders didn't have a built-in thing. That's not. I was told that the out was completely different. This works, I'm gonna be pissed, and it doesn't work. Yeah, you still can't see anything. Oh. Oh, come on. What the hell? Huh? Oh. Oh. Oh, are you gonna do this thing again? Oh, this is cool. Oh, this is real cool. Oh, you gotta be shitting me. Oh my god. That's a real bad crash. Yeah. So my title bar. Oh, this is bad. So this still doesn't work. Yeah, I have to use Alt-Tab. Okay. Okay. Yeah, there's all the stuff here. Gen buffers. VPO. That's the VPO, but I don't have a VAO. So where's all this stuff? Storage shader. I'm gonna do this down here. Heavenly Delusion?
Yeah, I was having a glitch with it, that didn't come out.
Oh. So we're shader. This is really bad, but I'm gonna do it anyway. I can just give you. This is Fragshad. This is Fragshad. This is Fragshad. This is Fragshad. Mainly, I need to be able to do these things for error checking and all that stuff, right? So. Okay. Where? Okay. This is actually that? Let's see. Let's take a look at, say, cell arrays. Okay, GLS cell arrays. Let's take a look. See what it is that I'm doing wrong. Because I think that's what I'm doing wrong. Yeah, just give me the damn. How do I freaking declare? How do I define arrays? How do I populate it? Huh? Because I'm a fat masochist. Oh. Can I just do this? Because, as I've stated before, I'm a crazy person who hates himself. Alright, let's see if this compiles here. And let's run it. See if there's any other errors. Yes! I did the thing. Okay, cool. Good. We're making progress. So I have a lovely little blue triangle. And that's lovely. So let's do this like here. And I can afford to make this bigger. Yeah. Cool. Yes! Oh, this is great. I can probably afford to make this maybe a little bit smaller. Like that. It's not a big fat head is going to be in the way, but it's fine. Okay, cool. Nice. Okay, I'm going to relaunch my doobly jam so that I can do the do with the doobly doo. Okay. So it's good for me to have the error correction. And error checking. Oh, I should have had the error checking a lot sooner. Okay. Cool. Perfect. Except, I think I need to... No. Cool. Perfect. Yes. Let's move this off of my big fat head. It's maybe a little bit smaller. Cool. Perfect. Oh, I have a triangle. Oh, hello triangle. It's amazing how happy I am to see that. Okay. So that works, which means that I should be able to say vec2 position. Make this positions Vec 2, and then this is GL vertex ID modulo 2, and GL vertex position vertex ID divided by 2. And then minus 0.5, right? And this should still work. Okay, cool. OpenGL is a colossal pain in the ass. Yes, perfect. Which means... I think that's correct. Yeah, that should be correct. Which means... times 4.0 minus 1.0. Oh, actually, I could do this times 4 minus 1. Because all these are in integer space anyway, so it doesn't really matter. I think technically it should be 4.0 divided by minus 4. Yeah, I mean, I might get it. I'm probably going to get a compile time error with the shader, but nope, it's a full screen. It's a full screen shader. Oh, this is absolutely perfect. Okay, cool. So, that means I can actually get rid of this. Right. Which means that here, the frag color equals 4. Right, so then we could do, I think, in order to do this properly, we need to have layout and stuff like that, right? Because we have the... Okay, so now I need to... Yeah, because it's all part of the layout. I don't need that. What I need is actually to have... Oh, I love him. I love hips. Quagsire. Okay, cool. So, yes. Nice. Okay, cool. No. Okay. How do I do this? I think it's just in Vec 2 and then out. Vec 2. Okay, so I can do in and out. Vec 2. This is SSUV. Aw. It's an Orion. Yes, that is security. The walls are watching you. I haven't even been streaming for an hour yet. Damn. No. I'm making progress. I drew a triangle. It's a big deal. That was like the one thing that was kicking my ass the last time I tried to do this. And it's like step 1 in OpenGL. It's bad. I love you. Okay, cool. Which means that SSUV is equal to the... Huh? Yeah, it just wasn't working. There's Slack. Oh yeah, no, the last 2 days were absolute bloody nightmares. Just all of the errors I could possibly have. I did, like, to the point that I had to, like, go into the config settings in Visual Studio and, like, delete stuff and move stuff around and, like, yeah. Like, I was, like, a step away from clearing the cache. Yeah, no, it was bad. It was real bad. Okay, so let's take a look at performance. Blah blah blah. Position +1 times text chord. Okay, so this means that the screen space UV. There are a few things I'm going to need to use here. So the screen space, and I'm also going to have to move all this into other code too. I just need to get it working, and then I will abstract all this away. And get it all abstracted away. I guess I can just delete that. And I can delete that. And then I can delete that, right? Because hello triangle. Because now I have a hello triangle. Okay. So, this is an important step. I have a triangle that fills the screen. Yeah. Let's build and boom. Let's rebuild it and let's rerun it and make sure that it still works. Okay, cool. Still works. Perfect. And don't worry about any of this stuff. This is all a bunch of ECS testing stuff, right? So I have that. So I have that. So I need to select all, copy, commit and push. Screen space 2D. Single shader screen space 2D. 4S 2D. And one more. One, 2, 3, 4. Okay, screen space. Single shader screen space 2D. Dirty. So, actually, I'm gonna make this more verbose. Single shader screen space 2D. Dirty. Okay, so here we multiply this by 4 and we subtract 1. Okay, that gives us the full scope of everything, right? That gives us the full doobly jam, full shebang. Still no one watching me. I'm probably gonna get a viewer right at the end of my stream. That's usually what ends up happening when I only stream for 2 hours. Okay, so what systems do I need, right? So for one, we have an out vec2 screen space UV, and have an out vec2, what is it? Well, the geo position is a thing. This goes from right, this is the interval from 0, 1, right? We also need an interval from -1 to 1, right? Let's need that one. Screen space UV. So normalized device coordinates NDC. This goes from have these here. And I'll just do that just for 6. Screen dist. Need to have the out to normalize screen distance. Ohio will be eliminated. Yes, I think plenty of people would like that to happen. Is Ohio even useful? This is from -1 to 1 from edges, right? This is from center, from bottom left. Right. All these are really useful, right? Then technically speaking, I should also have a uniform, but I'm not too worried about uniforms yet, because what I want to have is something along the line. Yeah, so one of the things that I want to have are these 3 things, right? So position is here, GL position is here. So let's do something like SSUV is equal to yeah. Oh, I mean, yeah. Well, ND full of pico to go.
No, pickle.
Pickled to go. Ooh.
Right?
Oh, pickled to go.
Right.
That I would say that would be 12 out of 10 because that sounds so good. Pico de gallo with pickles. Oh, I want it. Yeah, it can't be that hard. It's just pickles. Yeah, it's super simple. It's not even all that expensive either. All that's pretty cheap stuff. Yeah, we're gonna have to make that sometime. Get some chips. Yeah. Or something. We can figure it out. Do not honk at me. My life is worthless. I will kill us both. You might try pulling off the nipple and then cleaning it out some.
Did.
Oh.
It helped a little bit.
Oh, that's sad. It's just dying. Yeah, it's disappointing. Okay, so NC is just equal to. Yeah, it should just be position. Right? Okay. SSUV is equal to NDC times 2.0 minus 1.0. Should be fine. Yeah. And then NSD. Now, this is where things get strange, because you have to think about the fact that it is in reference, right? So negative numbers will be on the left hand side, positive numbers will be on the right hand side. And right at the center, you have, if it is less than, right, if it is less than, what is it? Right, if it's less than the center, then and it's all relative to the edges, but we know, right, we have the screen space UV, well, we have the NDC, right? So what we want to do is invert it somehow. So if NDC is greater than 0, we want to return so dot x is equal to if NDC dot x greater than 0.0, then we want to return NDC, and we want to return, we want to make it 1.0 minus NDC dot x, NDC dot x, otherwise it's less than 0. Right, because the edges are going to be 0. Right. Then so how do we go from 0 to -1 on the x-axis? So we start at -1. Be -1.0 minus NDC dot x question mark? I think that's correct. I mean, I'm going to be able to check it anyway. So NSD dot y is equal to NDC dot y greater than 0.0 trinary operator minus NDC dot y. Minus 1.0 minus DC dot y. Okay. And then here we have in vec2 SSUV and vec2 NDC and in to NSD. Okay. Let's build. Build it as you get no more errors. Is just what it is, right? And there's more to it, right? Okay, cool. So that works. No errors there. So vec4. Let's try 0. That's 0. Let's first do SSUV. Build. And then test. Cool. So that is correct. Yeah. Wait. What? That's not correct. That's not -1, it's +1. Wait. That's not that, it's divide by. Yeah. SSUV should be from... Oh, yeah, that's... What the hell? Let's just take a look at it. Normalized device coordinates. See if this is correct. That is correct. So I need to subtract one. Yes, SSUV is equal to normalized device coordinates. Subtract 1. So now this becomes from 0 to 2, and then we divide by 2.0. And then this should be SSUV. Screen space UVs. And this should be black in the lower left, and then it should be... What? No, it's not minus, it's plus. Because I'm an retard. Of course all those are negative. God, I'm a dumbass. Okay, yeah, that's correct. That's how it should look. And now, an SD. There's so much going on here. And yeah, no, like I'm making this unnecessarily difficult, and that's not proper. Normalized device coordinates is greater than 0. Minus D. Let's invert this just to see what happens. So it is that. So NSD is if normalized device coordinates NSD normalized edge distance, normalized edge distance, NED. Okay, so I mean let's talk about this, right? So we could do 1.0 minus the absolute value of NDC, normalized device coordinates, right? We could take 1.0 minus the absolute value of the normalized device coordinates. What this should do is that we should have you should see it coming in from the edges, right? NED. NED. Yeah, this is really important to have these error checkings. Should be right in the middle. We'll have minus NED. Okay, let's take a look at, say, Shader Playground. This is a fun time. This is cool. I like this, but I'm not gonna do that. GLSL, absolute value, abs. Turns the absolute value. The original support also allows for some other stuff. Gen D type. Okay, cool. Shader play, GLSL, Tyler, truncate, shader stage. Oh. Okay, this is a really crazy thing. Let's take a look at Shader Toy. Just gonna hop into Shader Toy real quick to figure out a few things, because this is not quite working the way that I want it. Okay, yeah. Okay, v equals that. Cool. So, vec3 col. It's vec3. T is equal to no minus absolute value of EV. Col equals vec3, and then this is T 0.0. Tester that no. What? Okay. Let's do this. Oh, I know. Yeah, the frag coordinate. Why is that a thing? God damn it. CV. Oh, vec2 NDC is equal to EV minus 1.0 times 2.0. In DC. Call that. Okay. That's the value in DC. In DC. Y. What? You mean 0. Device coordinates. So rad coordinates divided by I resolution xy. Wait, what does UV look like? Hmm. 0.5. And this is times 2.0. this should be MDC. Okay, that's correct. I know you can't see exactly what it is that I'm doing, but I don't care enough to show what it is. I'm sorry. Which means that I want T. Okay, yeah, so that works. So NDC equals a position. Okay, so what's going on? Okay, so I have a black screen. Cool. Which means that, let's say, wait, what does NDC look like? This should be that is correct. Okay. Which means if Ned is 1 minus NDC, what happens? Oops. If I make this Ned. That is also correct. What happens if I make this the absolute value of NDC? What happens now? What? Because it all shouldn't be 1. No.
No, it's like president.
Oh fuck.
We dropped it out to Monday after like another quick
Yeah. Okay, so I understand what's going on here. In essence, I can't. Ned cannot be declared in here. Okay. Because vec2 Ned. Can I declare this like this? Because I should be able to just say, no, minus the absolute value of NDC. Should be able to do that. Hopefully. Hopefully I shouldn't have to do this in void main. Yes. Yas. Okay. So. This is important. So now what I can do is I can multiply this by a thing, right? So we take this, right? And yeah, no. Okay. And then what I can do is ned.x times equals some boolean. Right, so I want to cast this as a float, and then there's going to be a condition in here, right? I want to cast this as a float. Right, so I want to say if DC greater than 0, if it is greater than 0, and then it's 1. If it's less than or equal to 0, it's miss. Well, I could do, nah, it's fine. I'm gonna favor the left-hand side, right? So then I can multiply by 2.0, and then I can subtract 1.0. And then nad.y times equals float and dc dot y dot x greater than 0 times 2.0 minus 1.0. So I think I need to actually cut that, put that in here. That's probably what I need to do. No. 9, 7. 1, 2, 3, 4, 5, 6, 7. I think it's not C-type casting, it's this type of casting. Which also means that I might be able to cut and then paste. I should be able to do this. Nope. Okay. Because I can declare things like that, but I can't evaluate things like times equals or anything like that, right? So cool. Now this does work. I think this is working properly, because it should be negative, right? So if I say minus ned, oh, 49ers lost. Yeah. Oh, fireworks. Cool. Yeah. Damn. And only scored 22 to 25 points. Mm-hmm. Okay, so I have these. And all those working. So these are all things that are useful for positions. I think that's all that's actually necessary. I don't really like how that's a thing. Like, I think it would be a lot better if I say back 2 and then this dot x times this. I mean, and I can also do some different thing. And then copy one, I think. Copy, paste this x with this y, and then x times 3 that. So all this stuff is things that need to happen, and then this should still compile and run just fine, and we should get the same result. Yep, everything's working. Perfect. Okay. So, is this done? So I have the screen space UVs, I have the normalized device coordinates, I have the normalized edge distance. Yeah. About left from center from edges. Well, I mean, this is technically zero, and this is open 0. This is 1. I guess I could do this, right? This is actually how it's working, right? Oh, actually, this is zero, 2, -1. And then this is actually this is open, and this is 1 to 0 from edges, right? A little bit of mathematical doobly jams. Right? Some mathematical notation here. This kind of mathematical notation is fine, right? So we have an interval from including 0 to -1, and then excluding 1 to 0. Right, so this goes from edges, both the x and y axis. And this is like really good for positioning things like UI elements and things like that. Now, these things can also be like it can also have a uniform that has the resolution, the actual pixel size, so you can set things to be a certain number of pixels and then position them around the screen accordingly based off of pixels. And you can also I love you. Guess we'll go like half an hour. Yeah. Alright, so let's just do that. Let's just have that, right? That's cool. That'll work. Okay, so we have 3 different coordinate spaces that we want to be able to deal with. You can do looks pretty. It should still compile. Let's see if it does. Okay, yeah, it does. Compiles. Okay, so let's explain why I have to, well, actually out Ned. Doesn't need to be a thing. Ned can actually be a thing here, which is an interval from 0 to -1 inclusive, and then from exclusive 0 to 1 inclusive. Distance from edges. Right? So I can move that there. Right? Because vec2 Ned is not a thing that even exists up in the fragment shader. The reason why it can't be in the fragment shader is due to the fact that the way that the reason why I can do these things in the fragment shader is because what it is doing is that for every vertex it is assigning one of these, and then when it passes the information over to the fragment shader, it's actually interpolating between them. So any like information and stuff that I handle with the vertex shader needs to be fully interpolatable, which, because of the way that Ned works, the way that it's calculated, I would need to have a vertex in the middle of the screen, and that's not something that I have, right? Because I need to be able to interpolate to the midpoint of the screen and stuff like that. And so I don't, since I only have 3 vertices, and I interpolate 0 to 0 or -1 to whatever, like it just doesn't work. Okay. So that is why Ned cannot be defined in the vertex source. It must be fully defined and calculated within the fragment source. Otherwise I can just have the vertex shader handle like all this calculations for me. And I'm going to be using this ideology, this concept, quite a bit in the world space, the world space single shaders. We're going to be using this paradigm quite a bit. So I think now this is good. So I can copy, commit all and push, and then I can delete that. So what's going on here? Okay. So, fun times. So, how do I... what do I do from here, right? I'm still gonna have to do some more OpenGL stuff. Right? But, what OpenGL stuff? I think abstraction. Then you need to start doing a lot of abstraction stuff, right? From center, bottom left from center. Distance from edge. Yeah, this is normalized device coordinates, and this is the screen space UV. Both of those are super useful properties to understand. There's going to be a lot of other things that I'm going to be defining within the fragment shader for things, right? Now, a lot of this stuff, right, because we have like these things and like all this stuff, and like a lot of this stuff needs to be pulled out and put in their own classes for like renderers and things like that, right? So things like this whole error correction, error checking things, this stuff needs to happen in like a lot of places. So, and all these things are super important to have, right? Because like this whole thing here needs to be a thing. Same thing with this whole section here. And stupid VAOs need to happen. And like this whole thing here needs to be abstracted in some kind of like window class. Right? I guess I could, let's compile, run, and see what's going on here. Alright, so we have, here's some text. So test has, here's some text. No. No, no, no. God damn it. Oh, this is not good. I don't understand why that keeps doing that. Oh, come on. Come on. Dude. Bro. Dude bro. Dude bro. Dude bro. Why are you so slow? Why is my mouse being absolutely glacially slow right now? What is going on? Oh my dear. Okay. Oh my god. So I don't understand what's going on with that whole thing. So here's some text. So the first one is here's some text. I delete the second one, which is very different text. It's fine. So I only have here some text. And then I add in the third one, which is even more different text. And then I re-add, huzzah, Far From Murphy, onto Unit 2, which the systems remember their crap. That's just a thing that exists, which I guess is cool. And again, like this whole thing is like really, really terrible, and I don't understand why it's doing it. That's cool. Well, since I don't want that whole thing to be crashing all the time, I'm just gonna deal with it. Scuffmaster 9000, I guess. So, let's take a look at what I have so far. So let's open up shaders. I need a shader class, a shader program, a vertex shader. No. No, no, no. Which is a thing of shader. Okay, cool. Okay. There are some other aspects of it, right? The shader program would have to handle VAOs and VBOs and EBOs. Alright. Oh, but that's the shader program would have to do that. Or would that be the renderer? Would the renderer have the VAOs? Oh, yeah, I can't click on things. Okay. OpenGL crashed, that's fine, I don't care. This is really useful. That's a super useful thing. Bufferless rendering. So nice, I love it. Okay, so I have rendering a triangle. So, the biggest thing about glute gluts. I don't like using gluts. Free glute. Free gluts. And there's also like loading in external files and things like that. Because eventually I'm going to want to have a little bit more verbose error checking instead of everything being in. Instead of having everything be in like this. Like I'm gonna want this in a completely separate file. Things like this can be baked into the executable itself, which is fine. But I'm going to want to have things like this be in different things, and I don't want this to be in a separate file altogether, and then I would have to load that in and all that stuff, which is going to be a colossal pain in the ass. Because I think there's like a way to add resources and things like that so it can still be baked into the executable itself, which is cool. I will definitely be doing that. Because like you'll just have access to the source code anyway. Like this is like not necessarily an open source project, but the source will be freely available. It's a freely sourced project, so you can just download the source and build it yourself. Alright. So things like shader. What's gonna go on here? Alright, the shader will have a source. And the source will be a thing. But I would also want to have the the const char pointer, the source be in here. So I might have different things be a little bit different. Right. This needs to be public. Otherwise you can't access the fragment shader. Right. Let's also take a look at shader.cpp. There's no implementation in here yet. That's cool. That's good to know. The shader prog. I got a shader pointer. And a shader frag. Right. Right, because shader program types. Right, we'll have a single shader. Well, I mean, we'll have render types. Right? So we'll have a single shader, screen space 2D. We'll have the single shader space 3D. Have the single shader world space 2D single shader world space 3D. Well, I mean, this is a little bit different, right? Because it's like, it's less of a single shader, more of a single mesh. Well, I mean, I guess it is a single shader. Right? Because you have, in essence, you'd have, like, all these would be full screen shaders, right? And they just cover the whole screen. And then you can just kind of infer a bunch of stuff from it. That's how most of the rendering is going to be. And then you just layer these renders on top of each other, right? Because then you'd have multi shader screen space 2D multi shader screen space 3D multi shader world space 2D and multi shader world space 3D. These are going to be the different types, right? So the single shader stuff, which is this is where most of my work is going to be. I'm going to be focusing on these a lot more. There's ways of doing like immediate mode for all this stuff, right? You just end up swapping through things like how dir I'm GUI works, and things like that. So there'll be different modes of doing these kinds of things. Right, have this. Right, this is where most of the stuff is going to be. Yeah. Well, I guess I can make this a plus. I can make this a plus, and then I can make this a plus, and then I can make that a plus. That makes things look a little nicer. Alright, what else do I need to do? Kind of wish I had marked when I got the triangle up and running. That that reaction was priceless. Okay, now this works again. God, that's irritating. So there are quite a bit of things, right? Because we also need to have like we have the Glue ID. We need to have compile, void compile. Alright, we have all of these things, right? We also want what is it, like a vertex array object we'll need, class vertex array object. We now have public ID. And then we also have, yeah, here soon. Here soon. Just like 15 minutes, 14 minutes. I love you. We have a void bind. What else do we need? Do the VAOs and VBOs need to be in the shader header? Should that just be within the renderer? I think add new item header file. Oh, this is called header. Rename render .h includes.h. Right. This is CPP render.cpp. Right. This would be include render.h. Right. Which includes render. We need to have class vertex array object public. Now we have a GL length ID. We don't want to have void bind. Alright. frames.h is fine. Render.cpp, render.h, render that. Shader.cpp, tools.h, ecs.h. We are done with the empty component system for now. We still need to have the tester app because we effectively just like copy and pasting a lot of this code over. We need to have these kinds of different renders because all of these will be cut and here. We need to have the vertex shader and fragment shaders. And we can have a lot of this stuff be done fairly easily. Alright. Once it's set, should be enable. There are some really cool things you can do. For instance, you can have these things be. You can modify these things at runtime. So if there are certain things in the code that don't need to happen, you can just make them not a thing, or you can add things programmatically into it. Yeah. So there are some really cool things you can do with OpenGL that you can't do with Vulkan, because you can't like dynamically. You can't have like self-modifying code or modifiable shaders at runtime. And for the most part, you don't need to. Especially now with Vulkan, the efficiency of Vulkan is really, really good. So. That's not really a thing that you need to worry about with Vulkan. And OpenGL works just fine without the ability to have self-modifying code. It's a little bit esoteric. It's not really necessary. What else do I need to have? Because there's a lot of parts to OpenGL. Like, OpenGL, as simple as it is very complicated. It's very in-depth, it's very complex. There's a lot of things that you need to keep in mind. There's like a lot of things like handling depth buffers and things along those lines. So there are ways to do it. Because, for instance, I could do things like, well, I don't like using glutes. Because there are things that, like, you could clear the depth buffer independently of the color buffer. And you would also, right, so you could clear the depth buffer every time that you draw a new layer, so that every layer, so you're just pasting stuff on top of it. So like between scenes, every scene at the end of its rendering cycle would clear its like depth buffer and stuff like that. Yeah, and one of the biggest things that I want to try and focus on with this whole project is that I want this to be as simple as possible. You okay, love? Yeah, I'll be done here in a little bit. Just like 5 more minutes, okay? So... yeah, so we have the attach all. We use... these things I'm not entirely sure if I want, because I will have to compile. What else do I need to do? That's all this stuff. Yeah. These things might be things in different stuff, as well as this. Right? Like all of this stuff might be handled in as a part of the scene. Well, not as part of the scene, as part of the window, which would be a part of the engine. And which would be dictated by the game. Right? Or even the game could have context of the window. Like the engine would have, all the scenes would have an instance of all the systems that that scene deals with. Right. And even though there would be a lot of overlap, because I want to have things like, you know, like you could have, like when you pause, you could halt what's going on in the background and things like that. So you can like pause physics, or you could have like the weapon wheel in modern Doom and like Doom Eternal. It slows down time when it's open. That would be a new scene, and as that scene is open, it could pass the information to the next scene after, which would be the actual game itself, and then the game itself could slow down its physics and all that stuff. So you should be able to have access to a lot of these things. I mean, it's the whole point of having the scene stack. It's a much more sophisticated state stack, which is the same principle that old school Pokemon games used, like Pokemon Red and Blue and Gold and Silver, probably all the way up until Gen 5, Gen 6. They might be using different concepts, or they might be using the same concept all the way through the entire series, to some extent or another. But much more rigorous in the older games of having a state stack. Yeah, and like the scenes will dictate different. Ooh, yeah, that's the thing. So only one scene will be receiving input at a time, which means the input callback for GLFW will be, well, I mean, even still, if you write it correctly, you can pass on the information to others, effectively creating your own callback system, so that should be fine. Instead of having one megalithic input handler, each scene would have its own input handler. And when you, in the callback, would just hot swap what handler is happening, because it would just use whatever the input handler is that's at the top. At the top of the stack. So you could pass information all the way through if you need to. Which I think would be a pretty clever way of handling it. Anyway, that's gonna be it for this stream. Maybe next week I'll have more people come in.